Right, good morning everyone. This is our tutorial for the discrete random variable. In the lecture on Monday, we have learned about what is the discrete random variable, what is the probability mass function, cumulative distribution function, expected outcome or mean, variance, and standard deviation. Well, we have learned about some rules and about probability distribution. We also learn how to come out our PMF, probability mass function, and how to draw the cumulative random variable graph. Okay, and I would like to refresh on this one. Some of you might confuse about the equation here. So I just cover it. So you have to remember that the equation to get the variance is your variable minus the mean power of 2 times the probability. You have to get the sum on this. Or else, you simplify this, you will get equation B. So it's up to you to use which way to get your variance. So for example, in the next example that we have discussed, actually we're using A. I'm much more comfortable with A because it's quite simple. You first write your variables minus the mean, power of 2, then you write back your probability, and then you get all the value and sum it. That is your variance. Whereas for equation number B, so it's x2, you have to times 2, times your probability minus the mean power of 2. Well, it's up to you which one you use, but the value should be the same, okay? So this is using the equation B to get it. Okay, so since we have done some example, so let's have a look on the let's try one. So for the let's try one, computer chips often contain surface imperfection. That is true. For certain type of computer chips, the probability mass function of number of defect X is presented as follows. Find the Px smaller than 2. Smaller or equals to 2. Right. So in this case, what should we do? So first, green, your favorite is green. So it's quite simple. We know that it's smaller or equals to 2. So we know that this one is smaller than this one is equals to 2. So therefore, I write x equals to 0 plus x equals to 1 plus x equals to 2. Okay? So then you can get your answer. Find the probability x bigger than 1. You can list down those bigger than 1. In this case, bigger than 1 is, let's say I change it to yellow color. Yeah. So bigger than 1, which one is bigger than 1? So 2, 3, bigger or smaller than 1, and 4. Or I can write it as 1 minus p x smaller than 1. So which one is x smaller than 1? So 1 minus p x equals to 0. And here you go, you get your answer. Okay? It's up to you which way you're comfortable with. So find the mean. And we have discussed about the mean equation. So the mean is the mean is the x plus the px, the summation. Right. Okay. So in this case, 0 plus times 0.4 plus 1, 0.3 plus 2, 0.15 plus 3, 0.1. Okay, so the mean is up to you to use which equation. So you can use equation B, or you can use where is it? Equation A or equation B that we have discussed. So in this case, so I just copy this. Okay, they will be easier for me. And then, okay, so what should we do now is, so first, draw the graph out, x, fx, or px in this case, x minus me, x minus me, x minus me, power of 2fx. Right? So I have 0, 1, 2, 3, 4. 0.4, 0.3, 0.15, 0.1, 0.05. Okay, so when once you have this and then you power of 2, and then you times, this is A, this is B. So A times B. Once you have the sum A, that is your variance. Okay? And for your SD, for your standard deviation, right? It's square root of standard the variance. That's all. So I'm not going to show you the answer, but the steps should be made you clear. Okay? So next, market estimate that a new instrument for analysis soil sample will be very successful, moderate, successful, or unsuccessful with the probability of 0.4, 0.5, and 0.1. Okay, so I can write this out as so successful equals to 0.4, probability of moderate 0.5, probability of unsuccessful is 0.1. Okay, the yearly revenue associated with the outcome is, so it's if 0.4, the outcome now is, what is the outcome? RM1 are 10 million. This one is RM 5 million. This one is RM 1 million. Okay, let's X equals to yearly revenue of the product. Okay, so I know that X is 1 million, 5 million, 10 million. Correct? So the probability of XX is 0.1, 0.5, 0.4, because the first question is asking you about determine the PMF of X. So in this case, this is my PMF. Okay, next we go to determine the expected value. And so the X, we are looking for the expected value, SD of X. So before we find the XD, we need to find the variance, right? So for the mean, so we need to find the mean first. Okay, this is A, this is B. So the mean is quite simple. 1 million times 0.1 plus 5 million times 0.5 plus 10 million times 0.4. And you sum up everything, then you can get, I think, 6.0067 million. 6.6. So what about the standard deviation? So for the standard deviation, again, we draw a graph, x, fx, okay? So 1 million, 5 million, 10 million. My fx is 0.1, 0.5, 0.4. Okay, so x minus mean, power of 2, x minus mean, power of 2 times fx. Okay, right. So you have your mean. Your x is 1 million. 1 million minus 6.6. You get your answer. Fill up everything. Okay, this is your A. This is your B. A times B. This is the summation A times B. And that is your variance. To get your standard deviation, you need to square root your variance. That's it. So your answer should be, correct me if I'm wrong, your check it, I think 6.0067. Check it out, right? Just in case I did something wrong on this part. Okay, so, right. Okay, number C. Let's have a look on C. So the C question asking is, plot the PMF and mark the location of expected value. Well, it's quite simple. What you need to do is, let me remove this. Okay. From here, we have the table. We know that our X is RM, million. Okay, 1, 5, 10. 1, 1, 5, 10. All right. So, and then we have, so this is fx, the probability, 0.2, 0.4, 0.6, 0.8, 1. Okay, so our probability 1 is 0.1. So I will say, let me use orange. Okay, about this part. So 5 is 0.5. Okay, so this part. 10 is 0.4. So this is my, you can draw as a line. Okay, this is your PMF graph. And what about your mean? Your mean is 6.6, right? So your mean, probably I use 6.6. So this is the center of gravity that make all the things balance. Imagine you have the a point to make everything balance between left and right. This is the mean. Okay, this is the PMF graph. So what about the graph for the D? Plot the graph, the big F. The big F is cumulative. What's that? Then we have to look back to the distribution, cumulative distribution function CDF. So this is the CDF, cumulative random variable. So in order to draw that, it's quite simple. What you need to do is still the same, 5, 10. Remember to write your units RM. Okay, so this is 1, This is 5. Because you already write million here, you just need to write 1, 5, and 10. So same thing, for the fx, we still use the same y-axis, fx. Be careful, this is cumulative. So the total is still 1, 0.2, 0.4, 0.6, 0.8. Okay, so we know that from this graph, okay, from this graph, I draw the graph again, the table again. 1 million, 5 million, 10 million. So fx is 0.1, 0.5, 0.4. So if you want the big fx, right? So we know that here is always 1, correct? So then this is 0.6y, and this is because 1 minus 0.6, and then you get 0.4, then you get 0.6. 0.5 minus 0.6 minus 0.5, and then you get 0.1. So 1 million is, you get so you draw a line here, and then 1 to 1 to 5 is 0.6. Okay, and then 5 to 10 million is 1. Okay, so this is your cumulative random variable graph. Okay, is there any question? So next, we move to question number 3. A resistor in a certain circuit is specified to have a resistance range 99 to 101 ohm. Student obtained 2 resistors. The probability that exactly one of them meets specification and the probability that neither meets specification is 0.16. Exact one of them is, okay, so I know that both is 0.3. Exactly one is 0.4. Neither, okay, is 0.1. So generally, I think I can label X is met number of resistor met specification. So if met both is, as we start with the 0 first, 0.16, 1 is 0.48, 2 is 0.36 px. Okay, so find the PMF. So find the PMF. So this is the PMF. We have done it. Okay, we have done it. Okay, the mean. So 0 times 1.6 plus 1 times 0.48 plus 2.36. Then you get a mean. Variance is simple. So x minus the mean, we need the power of 2, x minus the mean power of 2. And then we have to x minus mean power of 2 times fx. Right. This is A. This is A. This is B. So A times B. And you have the summation. That is your variance. Okay? So how to get your standard deviation? Square root of variance. Okay? That's it. It's the purpose of this tutorial is quite straightforward and easy so that you can remember, you understand how to use the formula and the basic, the fundamental of discrete random variable. I hope you understand it. Sorry about my handwriting. If you have any question, please just text me. We can have an appointment to discuss further. Thank you. See you on Monday.